Dear students, in this video I am going to explain about a topic called as FlowNet, which is comes under second unit. First of all, the introduction to the FlowNet. A FlowNet is a graphical depiction of water flow through a soil mass. It consists of flow lines and equipotential lines that form a curvilinear network. Flow lines indicate the path along which water seeps through the soil. The equipotential lines connect points with equal total head or potential head. Flow lines represent a trajectories followed by the individual water particles. Equipotential lines are contours joining point with equal potential or head. When we observing the diagram, the flow lines and equipotential lines are presented. This session shall enumerate about the FlowNet and its properties or characteristics and also applications. This topic is very important for all the upcoming examinations pertaining to civil engineering, including SSC JE, TSPSC, RRB JE, etc. When we observe the diagram, the bottom surface, which is impermeable layer, we are observing, and the structure called as a dam. The dam which will be store some amount of water. That water maybe passes under the dam and it will be create a type of flow net. The type of flow net which will be in the direction of x direction and also y direction. That is the way the water which will be flows in two-dimensional ways, and it will be form or it will be create a flow net. First of all, we need to understand about what is meant by permeability and what is meant by seepage through the soil. Then only we can understand the flow net concept. What is meant by permeability? Permeability is defined as the property of a porous material which permits the passage or seepage of water through its interconnecting voids. A measure of how easily a fluid can pass through the porous medium. That means we are taking example as a soil. It is a very important engineering property, and when we observe different kind of the soils, the gravel which is having highly permeable, the stiff clay which is having very least permeable. Then coming to the diagram, we are observing different soil mass, different permeable conditions will be there. The gravel which is having high permeable, and coming to the clay, the permeability is very less. Then seepage through the soil. What is meant by seepage? Seepage is the path of flow or path of water which will be flows in the direction of x or in the direction of y or in the direction of z. But we are taking only considering only two-dimensional way, that way a rectangular soil element is shown with the dimension of dx, dz, and the thickness of the soil mass is dy. In the x direction, the net amount of water entering and leaving the element is dou v x by dou x into dx, dy and dz. Similarly, in the direction of z, the difference between the water inflow and outflow is dou v suffix z divided by dou z into dou x, dou y and dou z. So this concept will be very clearly say about the seepage through the soil. For a two-dimensional steady flow of 4 water, any imbalance in flows into and out of an element in the z direction must be compensated by a corresponding opposite imbalancing in the direction of x. Combining the above and dividing by the dx, dy, dz, it is the continuity equation is expressed as dou v suffix x divided by dou x plus dou v z divided by dou z is equals to 0. Then coming to the flow net. What is meant by flow net? The flow net which will be understood by the knowing of the seepage of water and also permeability of the water. A flow net is a graphical representation of the flow of groundwater through a porous medium such as soil or rock. It consists of a network of flow lines and equipotential lines which will be intersect each other by the 90 degrees angle. Flow nets are commonly used to analyze seepage and evaluate the flow characteristics in geotechnical and hydrogeological engineering. They provide insights into the direction, velocity, and flow patterns of the groundwater within a given area. Flow nets are constructed using mathematical equation, numerical methods, or graphical techniques. By the continuation, they are particularly useful in the designing and assessing of stability of structures such as dams, retaining walls, foundations, bridges, and earth dams where the seepage control is critical. Flow nets helps engineers understand the potential for the seepage related issues and develop appropriating remedial measures. By analyzing the flow net, engineers can estimate seepage rates, identify the areas of the high groundwater flow, and evaluate the effectiveness of drainage systems. The flow nets are essential tools for the groundwater management, ensuring the safe and efficient utilization of the water resources. When we observe the diagram, the homogeneous dam which is having impermeable foundation and also which is having the drainage blanket. Wherever we provide the drainage blanket, there is a seepage loss is very less when compared to without providing of the drainage blanket. Then we observing here particularly or practically the water seepage from the water bodies and the properties and characteristics of the flow net. By knowing of the characteristics and properties, we can apply several ways or several things. The flow lines and equipotential lines in a flow net are always orthogonal or 90 degrees to each other. That is the first characteristic of the flow net. The flow lines and equipotential lines within a flow net do not intersect to each other. That means the flow lines which cannot be intersect each other as well as equipotential lines which cannot be intersect each other. Each flow channel which is the space between two adjacent flow lines called as a flow field. That flow field which will be represented by the square or it will be formed as a square. The flow lines and equipotential lines in a flow net are typically depicted as smooth curves. What are the uses of flow net? The flow nets are used for the quantity seepage finding, and once a flow net is drawn, it can be applied for the different flow rates. The continuity equation can be also used for the flow net determining of the velocity. The flow net analysis aids in designing of the optimal boundary shapes for the efficient flow. The flow nets help prevent the separation and identify the points stagnation when designing boundary shapes. What are the applications of the flow net? The flow net will be applied for different or several ways. For the finding of quantity seepage pressure we can find out. We can find out the velocity of the flow direction, and we can find out the hydrostatic pressure, and we can find out the exit gradient of the flow line, and we can evaluate the seepage related risk, and we can design the remedial measures also. These are the number of applications we can observe for the using of the flow net. Determination of the quantity seepage. There is a equation called as a quantity seepage or seepage loss we are going to be finding. That is the rate of seepage loss which is denoted with the Q. By using of the flow net, the rate of seepage loss or seepage quantity can be determined by using equation, that is Q is equals to small k into capital H into capital N suffix F capital divided by capital N suffix D into delta B delta L. Whereas K is the coefficient of permeability, capital H is the head loss or head causing the flow, and NF is the number of flow lines, ND is the number of equipotential lines, delta B is the width of the flow field, delta L is the length of the flow field. This equation will be gives the rate of seepage loss. Coming to the second one, seepage pressure, that is denoted with P suffix S. Seepage pressure at any point we can determine using below mentioned formula. That is capital P suffix S is equals to gamma W into H. We know very well gamma W is the unit weight of the water, and capital small h is the hydraulic potential. After n potential drops, it can be expressed as H is equals to capital H minus n into delta H. Whereas delta H is equals to what? Delta H is equals to capital H divided by ND. Delta H means potential drop or drop in head between two adjacent equipotential lines. Then coming to the next application or next uses, that is finding of uplift pressure, which is very important for the construction of dams or earthen dams or bridges or any kind of water structure. The uplift pressure is very much important. The uplift pressure at any point within the soil mass can be found using the formula, that is Pu is equals to gamma W into HW. What is meant by gamma W? We know very well, unit weight of the water. Small hw is the piezometric head or pressure head. How can we find out? Total head minus elevated head. That is hw is equals to h plus r minus z. And also one more application, that is finding of exit gradient. The exit gradient is the hydraulic gradient at the downstream end of the flow line, whereas seepage water from the soil mass joins with the free water at the downstream. Exit gradient can be expressed as small I is equals to delta H divided by L, whereas I is the hydraulic gradient, L is the total distance between points A and B, that is the length of the flow over which the loss of head occurred. These are the four applications we can observe. Then coming to the where we can apply this knowledge. The objective type questions will be comes like this. A flow net can be used for which of the following purpose? We know very well the flow net which is used for the finding of the seepage loss or quantity of seepage, and we can find out the seepage pressure, and we can find out the hydrostatic pressure. The answer is D, all of the mentioned. Then coming to the next one, the portion between two successive flow lines is known as. We know very well about the portion between two adjacent flow lines called as a flow channel. So the answer is B. Then coming to the who was the first to give a graphical method of flow net construction, that is Forchheimer. And one more is the flow lines and equipotential lines are which are perpendicular to each other. Like this, the number of questions will be comes in the competitive exam. So by this way we can flow channel means the portion between two successive flow lines called as a flow channel. Then who was the first to give a graphical method of flow net constructed? So here the answer is Forchheimer is the first given flow net for the understanding. And then the flow lines and equipotential lines which are parallel to each other, perpendicular to each other, elliptical to each other, or all of the above. We know already we have seen the flow lines and equipotential lines are which are perpendicular to each other. Like that, the number of questions will be comes. Dear students, you should be understand about the flow net. What is meant by flow net? For understanding the flow net, we should be know about the permeability and also seepage through the soil. The seepage water which will be comes or which will be travels in the two-dimensional way. That is the way the flow net will be forms. Thank you very much.